you will be able to do everything. And that's the trick with this stuff. So, for example, if I wanted to start with, what they're talking about here about the special quadrilaterals, that's parallelograms and non-parallelograms, and all the stuff we've looked at for this past week. When we start with a parallelogram, if I start with the parallelogram, what do I know about the properties of a parallelogram? Okay? Two sets of parallel sides, right. Uh-huh. Two sets of parallel sides, whiskey take the half. What else?
Angles are similar on each side.
On each side, the angles are the same or same?
Yeah.
No. Opposite.
Oh, yeah.
What else? What's that?
Oh, the cross.
They cross, okay, but what do the diagonals do? They bisect each other, very good. They're not necessarily congruent, but they just bisect each other. So you've got sides parallel, diagonals bisect, opposite angles congruent, and you're kind of missing an important two other things. Yes, sir? Angles are supplementary, very good. Consecutive interiors are supplementary. What else? The pretty obvious one here. Not necessarily, not in the parallelogram. Hmm? Well, yeah, that's okay, but something else here. Yes, ma'am. Not complementary. We've said the consecutive supplementaries. We've said that. We've said the diagonals bisect. We've said all the other ones. We're kind of missing a really important thing. Yes, ma'am. Sides. Opposite sides are congruent. Okay. So your parallelogram has all those parts. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Bless you. Bless you. Third time's charm? No. Opposite sides are, sides are congruent, sides are parallel, opposite sides, opposite angles are congruent, consecutive interior angles are supplementary, diagonals bisect each other, and a whole bunch of fun. After that, the parallelogram branched off into two different shapes. It branched off into the rectangle, not the square, the rhombus. It branched off into those two. Now, what makes a rectangle more specific than just a plain old boring parallelogram? Remember, it has all the properties of the things above it, but it has more specific things. For example, 490 degree angles, very good. The four right angles. And what else?
Two sets parallel.
It has everything above it. So,
Diagram bisects rhombus angle.
huh? Is that a rhombus?
Yeah. Not like, oh, that's a rhombus.
Bisectors.
The things are congruent, very good. The diagonals are congruent in a rectangle. So since they still bisect each other, normally what I do as far as drawing the picture out, I'm just going to put a single tick mark on all four pieces of the diagonals. That just shows that every part of all four of them are the same. Everybody okay with that?
Sure.
So now you have, now you wind up, if you remember, you get four isosceles triangles, but two of them are the same, and you had a lot of alternate interior angles and things of that nature to pop around with that. So that was pretty much there. Now the rhombus, what made a rhombus was what? Four congruent sides, very good. The rhombus had the four congruent sides. And what was it? Yeah, the diagonals are perpendicular, good. Your diagonals are perpendicular. And then you were mentioning this earlier about the angles.
Bisect.
This is the one that the angles are bisected in. Okay. The angles of the rhombus itself They're still, the opposite angles are congruent, but the diagonals bisect those angles. So the diagonals. Do you mind if I call those the base angles of the rhombus? Is that okay to call it that?
No.
Yep.
It's confusing.
You're confusing.
It's confusing.
I know. Here, we'll put it in parentheses, so it's like air quotes.
That's not perfect.
I know. We'll just use air quotes. So it's almost ish. And then the offshoot of the rectangle and the rhombus is the most specific one that we've looked at, which is the square.
Okay.
And remember that it is hip.
Wait, that's a square?
Wait,
No, it has 4 sides.
Mr. Murphy?
square has everything from above it. 4 sides equal, four angles.
If you look at the square,
Squares.
x length and top minus some values.
Diagonals that are congruent,
The top. Or just we start thinking of the right.
4 right angles, 45, 45s, and so on and so on. So the square becomes the most specific of those parallelograms. What's up, Whiskey?
I'm just laughing at your square because all the sides does not look like it's equal.
It's not drawn to scale, though. And we'll get over that.
You never said it wasn't drawn to scale.
You can just go ahead, there's very few things you can assume in this class, because we don't like to make angle side sides out of each other. But in this case, you can just, my drawings, you can assume that they're not drawn to scale. Thank you for the chuckle. Okay. By all means, you can assume that. Okay. It's not a bird, I'm just saying. Okay. It's nothing. It's just an explanation. Right. Now, if you go to the non-parallelograms, when we went to the non-parallelograms, we had the trapezoid and the kite. Now, the trapezoid,
Wait, Mr. Murphy?
yes, sir.
I thought we were not supposed to assume anything in math.
Right, but this isn't anything about math. This is about my drawing skills.
But your drawing also has a lot to do with math.
Whiskey. It's enough. Okay, it's enough. So a trapezoid has one set of parallel sides. Trapezoid will have one set of parallel sides. And I think the only other thing that I brought up with the trapezoid, just the basic run-of-the-mill trapezoid, was that if you treat the legs of the trapezoid, what I mean by the legs are the sides that connect the parallels, treat these as the two angles here and here. These are supplementary to each other. And the reason that those are supplementary is because they would be consecutive interior angles, by using the properties of parallel lines. Okay? That was pretty much the only thing that you were able to do when it came to plain old boring trapezoid. Now, the isosceles trapezoid was more specific. Get off your phone, Jason. And you can close the computer because we're not using it. The isosceles trapezoid was more specific. Treat it like you would the isosceles triangle. If you treat it like the isosceles triangle, you know you've got congruent legs. Again, the legs are the parts that connect the parallel sides. After that, then you knew that since you had congruent sides, you had the sides looking at what were called base angles. The base angles were congruent. And there was one other part that was congruent, remember? And that they don't bisect, but they are, just the diagonals are congruent. Okay. The diagonals in isosceles trapezoids, the diagonals are congruent. Okay. And that was the two parts of the trapezoids. And last but not least, the kite.
Oh, it's the cookies.
No, we didn't, even though the other day would have been really good at it, except for the fact you probably would have ripped apart and destroyed. Yeah. Oh, that stinks. Yeah. I spread that in the paper. I think it was like the power lines arced on the blacktop. It melted the blacktop. Yeah, it's crazy what it can do. There was a right here on Dresser. If you're going east on Dresser, one of the houses over here in Heatherstone, their fence got blown over in the wind. So, yeah, it's my gutters were. I found my gutter extensions about 5 houses down.
My house will.
We have
Indiana. Awesome.
You know what's even funnier? And the old burned down barn, the one with the last remaining beams that's still like sticking upwards.
Yeah.
It like literally flew across the field, across Twombly Road, across Rich Road, and it ended up in my little cousin's yard.
Yeah, this is crazy what the wind will do. So kites. Again, think of kites as 2 isosceles triangles put together. And the 2 isosceles that are put together have they would have a shared base, if you will. And when you look at it in terms of that shared base, if you drew that base in, if you drew that base in, that base is bisected by the other diagonal. And you have 4 right angles. And then the 2 angles the base that's shared between the isosceles, how that diagonal touches those 2 angles, those are the 2 angles that are congruent. The angles in between. And remember when we looked at the kite stuff, as you saw yesterday, excuse me, there was just a lot of right triangles, SOHCAHTOA, triples, things like that. It's nothing too crazy, but it's the idea that you understand all of the properties. Because if you know how to work with the properties, everything goes. Okay? Everything. So what I want to do is take a couple of minutes and answer these questions. Don't worry. Don't worry. You don't need to write this down. Me being as awesome as I am, made a copy of it for you. I know. I did forget the hole punch because I wasn't going to. Well, if you give me a second, I would explain. Reason why I did not hole punch is because our copy machines are not that great.
They're awesome, remember?
Yeah, there's something. So
Say they're awesome.
yeah, they're really not awesome. What I did was I just kind of went through and just made a copy. So let's take, I don't know, 3-4 minutes on your own and try to mark off what has what. Make a little X or a check mark. So if all sides are congruent, what shapes are there? Well, what I want you to do is add, the first one is a parallelogram. Okay? Rectangle, rhombus, square, kite, trapezoid. What I'd like you to do is make an extra column at the end here and call it the isosceles trapezoid. Okay? I'd like you to make one extra column at the very end. Should have room on the edge there. Call it the isosceles trapezoid column and go through the same questions and see, will an isosceles trapezoid have any of those properties as well? Okay? Let's take about 5 minutes to see if you can figure it out and we'll check it. All right. So, all sides are congruent. Who has it?
What shapes?
Rhombus.
Wrong. Just those are the only 2 that have all sides congruent. Both pairs of opposite sides are congruent.
Rhombus and
All right, so I hear if it's a parallelogram, then what else is a parallelogram?
rectangle, rhombus, square.
All of them have it. No, trapezoids only have trapezoid can have one set of congruent sides, but not both sets. Both pairs of opposite sides are parallel.
All
All the parallelograms again.
Oh, come on.
Oh.
Oh, gosh, that's cheating. There you go.
Exactly one pair of opposite sides parallel. The isosceles trapezoid, and if it's the isosceles trapezoid, it also has to be the regular trapezoid. What's that? All angles are congruent.
rectangle, square.
Rectangle, square. Exactly one pair of opposite angles are congruent.
Rhombus, trapezoid.
Exactly one pair, a kite. One set of congruent angles is a
I
kite.
noticed you didn't say opposite.
One set of
Exactly one pair of opposite angles.
Go right, but two pairs, like.
Oh, I didn't? No. Diagonals are perpendicular. Rhombus.
rectangle.
Whoa. Rhombus. Square. And what else?
Rectangle.
Kite. Rectangle doesn't have diagonals that are perpendicular. They have diagonals that are congruent. Speaking of, who has diagonals that are congruent? Square. Rectangle. Oops, wrong. I hit the wrong button. Sorry. It's not a right.
It's okay, we forget you.
So we have square.
Rhombus.
Oh, thank you. Diagonals congruent. We're square. Good morning, sir. What else?
Rhombus.
Rhombus didn't have diagonals that were congruent. Rectangle. And what else? Not the kite. Guys, you have all this sitting down, writing down the diagrams we did like 2 seconds ago. Be resourceful, people. Be resourceful. So we have isosceles trapezoid, square, and diagonals bisect each other was the rhombus. No, not rhombus.
Yeah.
Oh, I'm looking at the wrong one. I'm sorry. I read the wrong line.
Are we doing diagonals?
We're doing diagonals are congruent. I read the wrong line here. So diagonals were congruent in the square, the rectangle, and the isosceles trapezoid.
That's it? Oh, okay, I got square. Never mind.
And then the last was the diagonals bisect each other.
Oh, okay. Rhombus?
All the parallelograms.
Yeah.
Okay. All the parallelograms, the diagonals will bisect one another. Again, when you see a diagram or you see something, if it tells you that, hey, bozo, this is a parallelogram, then that means, yeah, I called you bozo, that's right.
I'm not.
So what happens is you need to know the properties to be able to solve the problem algebraically. As you've seen throughout the course of this chapter, the algebra is not that difficult. It's just a matter of knowing how you set it up correctly. Okay. So what I have you guys for tonight, kind of a little bit different. Yes. Your job this evening, I'm easy on you here. Fill out the family tree. Fill out the family tree.
No.
One of the, hey! Listen up.
I am listening.
One of the things to remind you of as we go through the family tree. Draw your pictures with it. Obviously, you might not have as much space on here to do everything. What I'm asking that you guys do is list out all the properties that everything has as you're moving down the family tree. And if it helps you as you go through, to draw a picture as you're doing it. Now, my suggestion, try to do this without looking at anything first.
Alright.
Yeah, it's possible. What I want you to, since we have the time right now, I want you guys to take the first 5-10 minutes or so and not look at your property sheet. And try to write down as much as you can without the property sheet, the one we just did, Jason. Okay? The reason I'm asking you to do that is because what will you have to be able to do come Tuesday? You'll have to be able to know how to do it, bless you. You'll have to be able to know how to do all of that. What's that? No? No? All right? So you guys have to be able to do that. So my suggestion is to try to do that. Not this one. I did that worksheet yesterday. Oh, it's on that. Right, yes. All right?
So you put this homework out.